So thank you everybody for joining our live panel. We're covering AI, big data, in Industry 4.0. We're joined here by some industry experts, which we'll introduce in a minute. We're going to cover what's evolved with these technologies, what has been successful, and what has not been successful. We'll also touch on some of the common hesitations and where leaders should be focusing going into 2021. So without further ado, let's jump into introductions. So again, I'm Tobias from Instrumental. I lead our solutions team, helping to deliver our technology to all of our customers, background in mechanical engineering. Joined here as well by Andrew Scheuermann, CEO and founder at Arch Systems. We've got Christophe Begue from IBM, Director of Solution Strategy and Business Development for Global Electronics Industry Team. We have Piyush Modi from NVIDIA, AI Computer Strategy and Business Development for Industrial IoT. And Remi Duquette, Vice President of Industrial AI and Solutions at Maya HTT. All right, let's go ahead and jump into it. And again, reminder, questions over in the chat that we'll address later on towards the end. So for the first question here, for AI, big data, other Industry 4.0 technologies, we want to talk about what's working well and what is not working well. So let's do a quick lightning round. We're going to go through all the panelists here. And if each of you could share an example of each. So let's start with Andrew, and then go Christophe, Piyush, Remi.
Yeah, sure. Thanks, Tobias. Great to be here with all of you. Example of something working and something not working, lightning round. One of the first things that come to mind of something that's working, combining data sets that have never been combined before, and then solving kind of needle in the haystack problems. Anna talked about this in her last talk of putting the right data sets together and being able to filter through them. So one example of something that we worked on that worked extraordinarily well is not a very complicated predictive maintenance, but a very simple problem of being able to find the worst feeders on pick and place machines worldwide in a large manufacturer. And we actually found a third of global attrition and a very small number of feeders that were just never maintained. We're having all kinds of problems. And it was simply the result of putting together data sets that hadn't been all analyzed in one place versus only on individual lines or sites where the people that knew what to look for didn't have access to it. So that's a category. I think that needle in the haystack data sets that weren't merged before aggregated. And then an example of something that is not working, I guess I'll pick the couple of things, but one of them that comes to us a lot is trying to jump straight to closed loop automation. That's kind of like exactly what people want to see at the end game for Industry 4.0, and automation teams have been doing that for a long time. Simple temperature algorithm. Okay, don't just tell me something's wrong, like shut off the oven or have a PID controller reset things. But with Industry 4.0, we're talking about dramatically more sophisticated amounts of data and algorithms, and the closed loops are not always so obvious. A lot of times it should be a human in the loop. It should be a maintenance ticket or something like that. And a lot of teams jump towards, there's got to be some way to millisecond closed loop automate this, or I don't think it's a good thing. And actually there's a ton of ROI that's missed when you kind of only look at that very narrow lens.
All right, so I go next. Hey, thank you. Nice to be with all of you. So in what's working, I would say, anything with visual analytics, pictures, videos, but also acoustic. It works very fast and it works very well. And maybe what's not working is the same thing, right? It's the ability to really put that at scale in the context of meaningful decision. So to Andrew's point, we can do quick analytics on many different things, but who is taking decision, how those decisions are implemented, not only on one pilot, but at scale across maybe 50 plants, complex product set in the context of a lot of legacy environment. So lot of technology works very well. Scaling, it's not a technology issue, it's a management issue, and that's not always working well.
Hi, this is Piyush Modi. Really excited to be here and sharing our insights. Been in the industry for last 10 years, focused on industrial AI and in digital transformation. On the count of what's working, really, if you look at the investment dollars going in terms of the startups that are getting funded, it's an amazing time to do innovative. What we see also is the compute element. The way it is becoming available from edge, like credit card size modules, which are like supercomputers of, let's say, the beginning of this century, to the super 500 nodes, which can have up to 5 petaflop of compute. So there's a wide range of compute availability and ability to harness with all the innovations that's going on in open frameworks to build this ever-increasing number of topologies of networks in deep learning side, which are bringing insights going from a few million parameters just a few years ago to now billions of parameters, whether it's image data, natural language processing data, or it's sound data, or speech to text, you name it, or even a recommendation engines. The AI technology is coming to finally unleash the power of what we invested in last 10 years in IoT sensors and the data. So finally, we can enable AI-led digital transformation. And lots of proof point and scalable solutions are emerging. What is not really working is there's a lot of, I think, lack of awareness or a misalignment, I would call it, in terms of not matching the technology to the right problem or having the right KPI identified, or ability to see through what a solution, how it goes from POC to scale, and not having those thought process up front and not working with the right tools many times, or not just having execution DNA to take the project all the way through to the outcome. This is where we see a lot of people, just due to simple misalignment, we see failures happening as well.
Cool. Well, it's a pleasure also to be here. Remi Duquette from Maya. We augment data sets, AI data sets, with simulation often. So just as a segue into this, what works really well, I mean, over the last 10 years, what we've seen work well more and more is the AI model creation itself, right? The model training, hyperparameter optimization, all the compute power that's made available over the last decade. Clearly, those things, like coming up with a good model that functions well offline from batch data sets or whatever we use to train, that typically works really well. We have tons of cases where, you know, these deep learning models, how simple or sophisticated they might be, they all work very well and can be made to work very well. What doesn't work very well is the transition into ML operations and, you know, AI operations, and the scaling of and the pipelines that feed those models in production, right? So we have and we'll probably describe hopefully a few of these disaster cases that we probably all had to face, where we have these beautiful models working in our sandbox environment or lab environment, but then when they're moved into a production industrial environment where the data is not going to be as clean as, and no matter how beautiful your data pipeline is, there's always going to be some corner cases that will pass through and will make it fail. So you know, that kind of failure of the implementation stage is what we're seeing more and more. And that's probably a good sign, in a sense of, it means more and more people are at that stage of deploying their models in production and leveraging AI technologies in real industrial environments. So hopefully we'll discuss a few of those interesting cases together as a panel.
Yeah, perfect. Thank you for sharing. Interesting to notice the themes of transitioning from the pilot onto the larger scale from both Piyush and Remi. Do you have a little bit more you want to share on sort of common things that you've seen to get ahead of in that transition, or common failure modes in that transition?
Well, so, I mean, yeah, we can, from a business and industrial AI, even when you apply best practices and putting all the risk mitigation measures in place, the very nature of data exploration often will lead to failure, right? So machines will be changed and the notifications will not be sent so that the model is retrained, right? They're very simple pitfalls that people will fall under. We have one of our battery manufacturing client that had a truly clean data set from one of their manufactured battery product as a quality prediction, with hundreds of beautiful real-time telemetry series. But in the end, none of those had a causal relationship with the actual quality issue that they were, having. So it was deemed initially a failure, and then in the end, we kind of stepped back with them and said, these early failures are absolutely normal. But if you step back and you look at your data again with a little bit of engineering simulation around it, we were able to figure out that the time series and the sequence of looking at the value as a function of time was actually not what led to that causal relationship. We looked at the values as a function of temperature instead, and all of a sudden, all of these beautiful models started to work. So, in any case, the real secret, is probably to just fail fast, right? And not find out that at the end of a long AI development cycle that you find these errors. So fail fast is probably a common topic that I'm sure, hopefully, the panelists here all agree on that is key to deploying successful AI models.
Yeah, if I may add, I mean, my suggestion would be you should look at three aspects on when you're starting the project. I don't like to see it as a POC to scale transition. It should be all thought through upfront. And the three areas you should have is really know your stakeholders and their expectations. What are these KPIs they're looking for? It's not about getting those accuracies to the best of the available possible way. Like, no, you don't have to solve 100% to meet the KPI that generates value for somebody. So understanding that, and depending upon the stakeholder, whether it's an OT or an IT stakeholder, the requirements are going to be different. OT person wants something to work, one thing to work, whereas IT may have a responsibility for all their stakeholders, and they're looking for a portfolio of things they are investing in with AI. So expectation is right. Second thing is, are we going to use the right tools that leads to the productivity? Because oftentimes we find people are reinventing cycles. They're trying to do skunk work using things which maybe, but as opposed to working with a curated ecosystem. So at NVIDIA, we've deeply invested in what we call NGC, NVIDIA GPU Cloud, which is a repository of all the known best practices of optimal frameworks, models, recipes, pre-trained models you don't have to retrain. So using the right tools, and then you want to know upfront the DNA. I've been in situations where technology did perfectly, but then it didn't have a path to connect to the IT systems, or it didn't have the approval from the stakeholder to blend it into the process. And therefore, the technology just sits for months waiting for all those alignments to happen. So you want to look at these three to avoid that kind of disappointment.
Yeah. One thing I would mention maybe is that Anna, as in our presentation, really focused that at the end of the day, brand owner will be the main will benefit and would pay attention to some of those metrics, and need to make sure that whatever the project is really focusing on the broader brand metrics. I remember a project where we were trying to spend a lot of time looking for defects that really were really rare. But the real impact for the brand owner was the ability to bring that product to that market fast. So we would have much more impact by reducing the total amount of testing, by focusing on the 70% of the product we knew for sure had no defect and were not in need of testing. And that would have a lot of impact on the total brand, while trying to find 1% of product that may have a defect was self-defeating in terms of its total impact on the process. So, redirecting on those metrics that have the most total impact.
Thanks, Christophe. Let's. So we have a question from the audience here on a similar topic. What would each of you consider be the two most important upfront factors for a successful concept to production deployment? Let's hop back to Andrew for your thoughts on that.
Answer this question plays well off of what Piyush and Remi were talking about before. I would say the two factors, one would be an initial use case that has ROI from the beginning. And the second would be a scalable architecture that lets you move smoothly from the pilot or phase one immediately into a rollout, no hitch in the middle. If you combine those two aspects together, the teams, they know they can justify it. There's excitement, there's able to be budget for it. And then you're not suddenly in this valley of death where you're like, we made a really impressive demonstration, but what do we do now? How do we actually scale this thing? And I think that both of these are completely realistic today. 5 years ago, there were a lot of companies just selling infrastructure, but they had no use cases. And then there were companies, consultants, Anna talked about like how these new platforms give you the impact of a big consultant with the scalability of a platform. There were lots of great consultants that could do a use case for you, but then after the use case, they'd say, okay, let's do a whole look at like what infrastructure we should use. And today, either inside the same company or in partnership, folks have come together to be able to provide end-to-end solutions and come forward and say, we've got a use case, whether it's a predictive quality, a predictive maintenance, optimizing utilization, optimizing labor efficiency, whatever it is, here's the use case that's going to drive ROI. And what we install in this pilot will be able to move forward and power all the different aspects of the solution.
Awesome. Thanks, Andrew. Anyone else want to comment on that original question of the two most important upfront factors?
Let's remember that in a lot of cases, the pilot, the POCs we're doing are happening in a distributed world, right? You have local users in faraway factories or sites. So understanding those users that are not necessarily corporate people with PhDs in industrial engineering, how are they going to react and participate to the scaling and the socializing of a solution after the initial success? So, and then what would be the roadblock to that scaling? And usually it's somebody we didn't think of up front, InfoSec, procurement, some guy who thinks that software should be written that way and suddenly has a big opinion. And that was not anticipated. So, roadblock to scaling that have nothing to do with the project, but will be impactful.
Yep. Yeah, I think well said by Andrew and Christophe, but if I may add one more thing, which is very important, is making sure you leverage the domain knowledge. Because as a technologist, it's always often we do believe that we have superhuman capabilities through AI once we have the data, but making the data meaningful, this is where the really domain experts can guide you. So building tools that increases their participation, their collaboration into this AI process is very, very important. Knowing what matters to them as an outcome, what are these various failure modes, etc., that you're trying AI to guide you on, and then having the system prove with their knowledge and domain expertise is going to be very important to the success.
Yeah, if I can wrap up, I think everybody has mentioned, the start with the business aspect, right? Make sure you understand your baseline, where you start from, right? And no matter where you go, at least you understand your baseline first. The relationship and the management of the staff and the stakeholders that will participate in the project, whether it's the people that will take action based on the AI result or the process that will be changed as part of that change in AI involvement. And finally, probably something that we're not touching yet, but the underlying data to serve that business case. Often now we do have a nice business case, which is great, and we have a baseline, but we may not have the appropriate data and the clean data to make it, right? People think they have big data, but often, number of failures and the number of issues is maybe not that big data yet. In some cases, in many cases in semiconductor we do, but in other industries not so much. And that, aligning the business need with the data and the change, those are the three key aspects, I think, that will make you successful in AI deployments.
Tobias, could I add just one more thing?
Yeah, go for it.
What Remi said about like the right data and what Piyush added about domain expertise, I think those are so critical. And your very first question was, something that's not working. Something else that I didn't say then was there's two extremes that folks fall into. There's some folks out there that still don't believe in AI and advanced statistics and what they can do. And that ship is already out there in the water. Like, this stuff works really well, and the people that aren't taking advantage are missing it. But then there's also the folks that think you don't need domain expertise and that a generic model can just do this. And I think everybody here knows it's the marriage of those two where the magic resides, knowing how to pick your data and apply it. And so those are just two pitfalls for anyone out there. Like, all domain expertise, this AI stuff is silly. It's for people that don't know the field. Totally wrong. It's the most powerful tool out there. At the same time, the marrying it with domain expertise is what lets you find the right data and execute on these pilots and use cases. And I think that's probably a theme we'll all touch on again, but I just felt like that should be emphasized one more time.
So that's an interesting point. And that gets to my next question here is, how do we, each of you guys come from AI products in a pretty different application. How do you evaluate whether the AI works? Like, you guys had talked about setting expectations, but how do you actually evaluate that? Maybe let's hop back to Piyush first on that one.
Yeah, I think you have to pay attention to your end user, right? And as I said, there could be three different stakeholders: IT, OT, and innovators. There are a lot of work we do is with the people who are advancing technologies. And in their book, the success is moving technology from TRL-X to TRL-Y, technology readiness level. And they have accomplished, they've learned something which has a huge impact to the whole science. Whereas when you go to the OT person, really, it's very different. And I remember this very good phrase when we're trying to get them to adopt wearables back in, I would say, 2015 timeframe. And really, the phrase was, once I put something back, I'm never picking it up again. And what that means is you really lost your good chance to get back to that person for another year or two with that same technology. So it better work and it better do what it does and not create unnecessary burden on them for using the technology. And on the IT side, really, it is a portfolio investment. This is about the trust with their constituency that they are serving across all the manufacturing plants or different leaders in reliability or production. They better guide them with the right set of portfolio, and their ROI is not on just one use case from the IT perspective when they justify this transformation journey. So you want to really serve all your constituents, knowing what matters to them. And if you serve them from that perspective, that's how kind of you can say this is working, right, for that end user.
Yeah, I would agree. I mean, working from home, as Piyush said, there's a range of users, the process engineer, the quality person, the brand owner, or maybe the AI center of competency who's really enamored by the first try of a new technology. So, working from home, and then working how over time. So how does it get deployed in the context of a data infrastructure? And how is that going to work over time? So think about the metrics of the AI, but how does that translate to different constituency, and then also over time? Because I think Piyush may have said that earlier. If you miss your chance and the project was very successful in the first 6 months, but after a year people didn't quite use it, then it's not that useful, right? It was nice, but it died. And then one thing I think Andrew mentioned is that it can be working, but is that leading to better action? So how do we transform data into insight? Okay, AI can help, but how do we automate the action such that somebody is making a decision at the right speed. So I don't know if it's milliseconds or seconds or 5 minutes or 2 hours, doesn't really matter. It matters depending on the industry, but how can we enforce the insight in the form of decision down to where it's executed? Which very often is the different set of technology, so it's difficult to close that loop.
Yeah, industry and use case, right? Yeah, it's like everything has its own time cycle, like you said. Some things are week by week even, and some things are milliseconds. But what's the action that needs to get driven, and how do you connect that loop? Which is I think a lot of the Industry 4.0 is being led by advanced manufacturing engineering teams, but when you have like Piyush, you said IT, OT, and innovators, exactly those three together, then you get really good stuff.
Yeah, I remember one guy at TSMC who was telling me, what's stopping me from having better AI being executed is the speed of light, because things are moving very, very fast. So I cannot go very, very far from that machine in order to run some AI and come back, right? There is a piece of fiber in the middle, and it goes at a fixed speed.
All right, we've got some great questions from the audience here. And reminder to everyone else, we're going to leave about 10 minutes for more questions from you guys. So please start posting those in the chat. Let's see, one from Kathy on resourcing. So with a finite amount of resources, what is your mindset when you're deciding how much or what data to collect when you start setting up the line? Maybe let's circle back to Remi on this one.
Well, how much data is always a big question, but it's it's one that we have a very practical approach in terms of the amount of data. We always say, use the minimal amount right now that will get you faster into a deployment, and that may mean restricting the number of inputs, right, to get a result faster and get perhaps a simpler model up into the production line, and getting people just that adoption rate, right, get those people used to what they have to take as action to then deploy. And so the amount of data, of course, will vary with different problems, and we do multiple discrete manufacturing stages. So often it's actually multiple people that need to coordinate. So it's not just one person clicking on the button every 5 minutes. It might be a coordination of multiple people in that production chain, which need to take action to resolve a problem. So so my recommendation is always, start with the minimal amount of data that as a subject matter expert, can lead to cause and effect relationship and control of whatever you're trying to solve. And then add stuff as you go, right? So again, in my analogy of failing fast, that's really where you want to go, I think, as a starting point.
Thanks.
Others will disagree, perhaps, and use everything you can. But
I would say, actually, it's always a good practice to start with a bounding box. So there is no amount of data is good enough, most people will say, but it's about having the right data and learning. So it's about series of hypotheses you're trying to validate and negate as you go through it. You can have a good vision, but start with saying, hey, in 4 weeks, I can't get to my first MVP. I'm doing something wrong with that hypothesis. You should be able to get whatever data you need to do that. There will be cases like where your infrastructure is preventing you from it. But if you are really constrained for budget, camera is a great sensor. You should be able to do a project on a factory floor with that in no more than 4 weeks, to the outcome.
I want to throw out an opinion here. I think I couldn't answer this on a generic basis. I think it really depends case by case. And this is where that domain expertise comes in. Like, you think about the underlying problem and set of problems that you want to solve, and what's the technology to be able to collect that data. And we have definitely done projects where we collected as little as possible, which was sometimes exactly the right decision, but we've done others where then we left ourselves having to make a major infrastructure upgrade to be able to collect more data. And so in that case, it made sense to put in place a more scalable platform. And another thing that happens, actually, this happens a lot when enterprises try to build their own, build versus buy, instead of partnering with a technology vendor, is they'll build a very like minimalist data collection system. They have one use case in mind, and they'll grab a couple fields, maybe throw it up into a Snowflake warehouse and plug it into like a Qlik or a Tableau. And they'll be like, okay, great, I'm done, and I solved this in a really efficient way. But they're really far away from being able to efficiently store all kinds of process data or images or other things that folks are talking about and feed those into an analysis pipeline. And they don't necessarily realize how far away from that they are. So I guess that's kind of what I would say. I think everyone probably is saying here too, like use case driven, and you don't collect data beyond your use cases, but you do want to think about your set of use cases and not be naive about the fact that some of the minimal data collection systems that can be set up with a lot of cool tools out there have you kind of surprisingly far away from like a large scale scalable data collection and analysis system.
Yeah, so maybe do not limit or constrain your data infrastructure by the data you will need for your first POC, right? So
correct.
Good summary.
Yes. Yes, absolutely.
So
and reason I said 4 weeks is because I think I agree with Andrew, everything you said, but really you can spend a lot of time thinking and planning and never get to the going. And this is really also about data-driven culture and outcomes. So a lot of organizations, especially in our domain, industrial and manufacturing, needs to start getting comfortable and understand what are these tools, what are these new workflows, and what you could achieve. And in that spirit, while you are planning, I would say you should still give a lot of value to executing on a 4-week MVP as your first level. There are many excellent one-day courses available. For example, like NVIDIA, we do Deep Learning Institute, where we come in on-site, do a one-day course, leave you with a lot of GitHub code, tools, data set, and which kind of helps you not only understand and get familiar with the concepts, but also get you start to envision your own situation in that context and then execute on a solution. There are a lot of great solution delivery partners that we have who come in, do a one-day workshop, envision, work with you, and give you a list of use cases that can go from 2 months to all the way up to 2 years in terms of enabling your entire digital transformation journey. So investing in something like that, bringing all the stakeholders together early and executing while you are planning out your exact plan is very important, I think.
Thanks, Piyush. So slightly related to this, if the leaders in this room are thinking about where to get started, obviously resources are on their mind. Selecting which area can be influenced the most readily. Do I need to work with one company that gives me everything, like my ERP software does? Maybe let's start with, maybe let's go back to Andrew on that one.
Yeah, that's a big question. I think the answer is yes and no. So everybody in manufacturing likes to work with one company, and there's a good reason for that, because these projects are complex, and when you can trust somebody to stretch from scalable infrastructure to use case, that's extraordinarily powerful. But I would differentiate that point from one company has to provide every single kind of use case, industry 4.0, stretching, machines, quality, maintenance, HR, finance, That's where you get in a lot of trouble. So modern software is about microservices and like best in class teams and companies that you can work with in different areas that have interoperable APIs that work together. That's not necessarily the same thing as having to put together 5 companies just to do a single project. But so let's just say it's a yes and no. I think it's good to look for, I guess these would be the 2 takeaways for me and hear what others have to say. One, it's good to look for vertically integrated end-to-end partners. They combine the data expertise and the domain expertise to get a whole problem done. At the same time, you should be building an IT, OT infrastructure built on this idea of APIs and microservices that's built for a modern software world so that you enable yourself to work with best-in-class providers in each class.
Yeah, I mean, I would agree with Andrew. We'd say the same thing, right? I mean, best of breed is average best of breed, right? Because so one single application for everything. It's okay. Well, somewhere I'll probably be the best, but on average, I'll be average. And so, but you want with vertical solution, as Andrew said, not to be isolated. So you need to have one way of bringing them together. A bit of good planning, a little bit of underlying infrastructure, and then partners are well open enough to coexist with what I know and I don't know, right? Because next week, next month, next year, I will have another set of partners. So how are they all going to coexist in my infrastructure?
Yeah. Yeah, I would add to that is like, let's say if you are buying ERP, and many large organizations, I know they don't have one ERP, they even have many. So if there is a solution you find, and there are quite a few, which matches your immediate pain point and outcome you seek, maybe it is reliability related, or maybe it's a quality related, you by all means go with that company you trust and you think can execute on that problem, maybe business problem. But AI is really about data-driven culture that you want to embrace. It is a fabric. It's going to go through your entire organization. So the question is, do you want to be the AI first company, AI led company? And in that case, you really need to, you just can't delegate that task to one company as such. The whole culture needs to come about, because there's going to be so much IP you are going to be creating, so much new opportunities and adjacency businesses you could be creating, especially for capital intensive industries like manufacturing, where a data-driven business itself is an asset now. And you could be unlocking values based on all your capital investment in a way you've never seen. You don't have to do all the hard work we do in making product, selling and making money, but you could also be doing in parallel so much with the software and related intelligence that could create new business opportunities for you.
I'm seeing two themes here. There's the kind of the community and the people, right? And from that standpoint, there's a very vibrant community, and pick and choose a couple of experts in different companies. I don't see a problem with that in the sense of you augment yourself as a company with the best that there is, and the community is so vibrant and sharing all sorts of different best practices. I think we can all get along. At the end of the day, of course, the underlying technology stack, and Andrew, I think a very good point on figuring out that technology stack that will work for you and for your purpose is key. And then after, bring the people that you need to put this in motion, whether it's 1, 2, or 3 companies. I think we have a very vibrant community of AI experts in here, and I think we would all get along in one project, on this front. So anyway, that my 2 cents at the end.
Thanks. Yeah, thanks for sharing. So we've got about 5 minutes here. A few audience questions, some good questions here that I want to hit on quickly. Let's go with a question. So assuming that not everyone in the company has a strong data background, we're looking for an example from one of the panelists here. Provide an example where you've been able to bring in other team members into the conversation to consult on collecting the right data. Anyone have an example on bringing in other teams to consult on this? Or experience working with another partner where they had to bring in other teams to consult?
There was one specific case where we needed to mix and match real-time telemetry data from the shop floor and the ERP data from the tickets that were collected on maintenance and other components. And there, I think everybody needs to assume dirty data until proven clean. Anything that has manual human interventions and more than 5 years history should be, let's say, a move to, let's say, a mode of the data is dirty until proven clean. And if you go into that project with that kind of mindset, we brought in an external partners for that NLP cleanup on the ERP data set that was needed. I'm not sure if I'm answering exactly the question, but that's the one case where we definitely brought in an external partner into our team for that NLP data cleaning aspect.
Got it. Yeah, thanks for sharing. That's yeah, one other thing that I did want to touch on before going back to the audience questions, common hesitations and misconceptions. There's like security, bandwidth requirements. What are the biggest misconceptions that you guys encounter when working with leaders at companies? Maybe let's go back to Piyush first on this one.
Yeah, I think we are talking about manufacturing environment where by de facto stand everything has to be protected, secured, and given that we are now adding new workflows and new data-driven assets like models, which may come from third parties, so everybody wants to protect their IP, and yet you want to do this in a most performant manner. People are not going to open up their SCADA network for any kind of vulnerabilities. So in order to do that, at NVIDIA, for example, we are envisioning to support this workflow, the entire life cycle of a models, all the way from building it to deploying it, protecting its IP, and securing it, and continuous learning of it. We are putting something we call Fleet Command, which manages the health of this model, looks at its performance, and it gives you Kubernetes-based control, and also allows ISV ecosystem to participate, where they can create Helm charts, simply create a benchmark in certification lab so that configs, etc., gets articulated and it's secured. We are also taking it all the way down to the hardware level, where with our acquisition of Mellanox, are able to integrate TPM capability, marrying it with our GPU for inferencing, all in one system. So the traffic gets offloaded from CPU so that it can be encryption, decryption, encoding, decoding, all that can happen at wire speed. Data can move where the compute needs to happen. For example, could be GPU, without having to incur losses in going through PCIe latency. So all this capability enabled with a software managed, those are the systems. There's a lot of interest in this in entire hyper-converged infrastructure community. So definitely it is a very essential tool, a necessary kind of technology that we must have, which is the enabled security and scale.
Thanks, Piyush. I think we are over time here, but thank you for all the great questions. We had a few more unanswered ones from the audience. I encourage you guys to stick around later this evening. I think when this wraps up around 5:30, there's some networking sessions, and maybe our panelists here will be around. Otherwise, you can direct message and we'll try to address those. But this has been great. So thank you, Christophe, Piyush, Remi, and Andrew, for coming to join us here and sharing some of your industry knowledge with the rest of the leaders here at Build Better.